5-2, direct variation. So our objective for this section is to write and graph an equation of a direct variation. And our essential understanding is that if the ratio of two variables is constant, then the variables have a special relationship known as direct variation. So direct variation is a relationship that can be represented by a function in the form y is equal to k times x, where k is not equal to 0. Or else, if you multiply x by 0, you would always get y is equal to 0. Pretty boring. The constant of variation for direct variation, which is k, is the coefficient of x. By dividing each side of y is equal to kx by x, you can see that the ratio of the variables is constant. Y over x is equal to k, no matter what y and what x you have. To determine whether an equation represents direct variation, solve it for y. If you can write the equation in the form y is equal, in the form, there we go, y is equal to kx, where k is not equal to 0, it represents direct variation. Okay? And simply put, direct variation means that as one value goes up, the y, then the x goes up as well, right? They vary directly. Okay? And the k, the constant of variation, is there to make the two sides of our equation equal to each other. So, does the equation represent direct variation? And if so, find the constant of variation. So what we want to do is we want to get y by itself. So in order to do that, we are going to divide both sides by 7. So y is equal to 2 over 7 times x. So yes, this is direct variation because we have y, we have x, we have a constant, and my constant k is equal to 2 over 7. Now for part B, we subtract 4x from both sides, and I have 3y is equal to negative 4x plus 8. Dividing everything by 3 gives us y by itself, but that gives me negative 4 over 3x plus 8 over 3. This is not direct variation because we have this other thing going on right here. We don't have y is equal to something times x. Okay, we have something times x plus something else. Okay, that is not direct variation. This is a line, it is a linear equation, and we'll look at that more in the next section. Okay, so does 4x plus 5y equals 0 represent direct variation? So here we have 4x plus 5y equal to 0. Subtract 4x from both sides, and we get 5y is equal to negative 4x, and divide out the 5, and we have y by itself, and we have negative 4 over 5 times x. That is direct variation, and my constant of variation is negative 4 over 5. Whatever number happens to be in front of the x. To write an equation for direct variation, first find the constant of variation k using an ordered pair other than 0, 0, because 0, 0 doesn't really give us any information that we know is the solution to an equation. So, suppose y varies directly with x, and y is equal to 35 when x is equal to 5. What direct variation equation relates y to x? And then the second part is what is the value of y when x is 9? So we know that this is direct variation. So we know that y is going to be equal to some constant times x. So the first thing we need to do is find the constant. Well, we have a y and we have an x. So I can say that 35 is equal to some constant times 5. Divide both sides by 5, and we have that my constant is equal to 7. So the equation for direct variation is going to look like that, replacing my constant with the actual constant, which is 7. And then to answer the next part of the question, well, y is equal to 7 times 9. Okay, so y is going to be equal to 63. Okay, so that's the value of y when x is equal to 9. Let's look at that again. I got a problem. Suppose y varies directly with x, so I know my equation is y is equal to k times x, and y is equal to 10 when x is equal to negative 2. Divide out the negative 2 from both sides, and we have that my constant is equal to negative 5. Okay? What is the value? Oh, here's my equation. Y is equal to negative 5x. What is the value of y when x is negative 15? So now we just plug in negative 15 and multiplying negative 5 times negative 15 gives me a value of 75. So, weight on Mars varies directly with the weight on Earth, x. The weight of the science instruments on board the Phoenix Mars lander on Earth and Mars are shown. 50 pounds on Mars, 130 pounds on Earth. Less gravity on Mars, things weigh less. Varies directly. When we see those words, y varies directly with x. So Mars is y, Earth is x. So y is going to be equal to some constant times x. So the weight on Mars is going to be equal to some constant times the weight on Earth, x. Now, this constant is going to be a fraction or a decimal, however we want to. Let's use a decimal. So we take 50 divided by 130. So we divide both sides by 130, and we get a decimal of about 0.38. Okay, so there's my constant, and I forgot to put the questions in here. Okay, so question A was, what is the equation that relates the weight in pounds on Earth to the weight in Mars? So my equation is going to be 0.38 times x. There's my equation. And the second part was, what is a graph for this equation? So if I wanted to make a graph for this equation, I would start, well, it doesn't make sense to have negative weights here, right? So if x was 0, y would also be 0, okay? If x is 50 pounds, if we plug 50 into my equation, we would get about 19 on Mars. So let's go 50, 100, 150, and let's make it 200. And then let's go up by 20s. 20, 40, 60, 80. Okay, so at 50, we're going to weigh 19 pounds. Let's plug in 100. At 100, we're going to weigh 38 pounds. That was pretty easy. So you can see, let's get a little room here. At 150, we're going to weigh about 57 pounds. So at 150, we weigh about almost up to 60. Okay. And you can see that we have a linear relationship here, and we can draw a line through all of the points. Okay. Let's look at the guided problem. Weight on the moon varies directly with the weight on Earth. Same thing, less gravity on the moon, more gravity on Earth, so stuff weighs less. So y is going to be equal to some constant times x. A person who weighs 100 pounds on Earth weighs 16.6 pounds on the moon. Okay? Divide both sides by 100, and we get that my constant is 0.166. What is an equation? So my equation is 0.166 times x. And what is the graph? So same idea is we're going to have, I don't want to do the whole thing, but we're going to have a linear relationship that goes through 0. Because if you weigh nothing on Earth, you weigh nothing on the moon. If you weigh 10 pounds on Earth, you weigh 1.6 pounds on the moon. If you weigh 100 pounds on Earth, 16. Uh, my weight, if you weigh 215 on Earth, I would only weigh 35 pounds on Mars. Or on the moon. Way too late. For the previous problem up here, my part B says, what is the slope of the graph? So if I look at this, if I wanted to calculate this, I have a bunch of coordinates, and if I calculate y2 minus y1 over x2 minus x1, we are going to get 19 divided by 50, which is 0.38, which is the same as my number right in front of my x, my constant of variation. Okay, so the slope is going to be 0.38. And how is the slope related to the equation? The slope and the constant of variation are always going to be the same. Okay? So, to recap here, the graph of direct variation is a line with the following properties. It always passes through the origin, 0, 0, no matter which one we're looking at, and the slope of the line is k. If k is positive, that line is going up. As x goes up, y goes up. And if k is negative, that line is going down. As x goes down, y goes down. Okay? So we can rewrite a direct variation, y is equal to kx, dividing both sides by x, as y over x is equal to k. That means every ratio, y over x, is always going to be the same thing. No matter which 2 points you pick out, you're always going to get k, the constant. So when a set of data pairs, x comma y, varies directly, y over x is the constant of variation, and it is the same for every data pair. So for the data in the table, does y vary directly with x? And if it does, write an equation. So all I need to do to check this is to check to see if y over x is always equal to k. So we have 6 over 4, which is 1.5. Well, that's great. Now we need to check, is 12 over 8 1.5? Yes. Is 15 over 10 1.5? Yes. Okay, so all the data points give me a constant of variation of 1.5. So that means my equation is y is going to be equal to 1.5x. Okay, let's look at part B. Okay, so again, I'm going to check this. I'm going to check and see if each data point is equal to a constant. So 3.2 over negative 2 is going to be equal to negative 1.6. And already I can tell this is not going to work because 2.4 over 1 is 2.4. So this is not direct variation. And in fact, 1.6 over 4 is also something different. This is not direct variation. So I can't write an equation for it. Same thing, does y vary directly with x? So we have 2.25 over negative 3. And that gives me negative 0.75. Negative 0.75 over 1 is negative 0.75. And negative 3 over a positive 4 is also negative 0.75. So yes, these all match up. So the constant is always the same. So my equation is going to be y is equal to negative 0.75x. Okay? So my lesson check, does the equation y is equal to 16, 18, 6y equal 18x represents direct variation? Yes, divide both sides by 6. And my constant of variation would be 3, 18 over 6. Um, suppose y varies directly with x, y is 30 when x is 3. So that makes k equal to 10. So my equation is y is equal to 10x. Okay. A recipe for 12 corn muffins calls for 1 cup of flour. The number of muffins you can make varies directly. This is a really important thing. Okay, so if you have these word problems, obviously this section is all about direct variation, so this is the way we're going to do the problem pretty much no matter what. But if you're taking some sort of test and you see these words very directly, this is what it means. It means to use these techniques. So that's what you want to look for. Okay, so you want to look for something that says varies directly in order to use these tricks. So 12 corn muffins, 1 cup of flour. So the number of muffins you can use varies directly with the amount of flour you use. You have two and a half cups of flour. How many muffins can you make? So we can set up my equation is that my input is flour, my output is corn muffins. So y would be equal to some constant times x, because this varies directly. So 12 corn muffins come from 1 cup of flour. So divide by 1, right? K equals 12, which means that to find the next equation, 12x, I just plug in 12 times 2.5, and I'm going to get, so I would get y is equal to 12 times 2.5, which would be 30 corn muffins. Does y vary directly with x? Y over x, negative 1 half, negative 1 half, negative 1 half. Yes, and my equation is y is equal to negative 1 half x. For number 5, the order pair 0, 0 is the solution of the direct variation. So is this always true, sometimes true, or never true? So this is a little sneaky here, okay? So while 0, 0 is always a, always a solution, right? So your equation is always going to be y is equal to k times x. So 0, 0 is always going to be a solution of any direct variation equation. But the opposite of that is not true. If you have a point 0, 0 on a line, it does not necessarily mean you have a direct variation equation. So always, sometimes, or never true. You can write the direct variation in the form y is equal to k plus x, where k is not 0. That is never true. So this is always, and this is never. Okay? Uh, it's k times x, not k plus x. The constant of variation for a direct variation represented by y equals k over x is y over x. Okay? That would normally be true if one of them, or if one is 0, the other is 0. If one of them is, say for example, x is 1, then we're not necessarily going to have a fraction. Yeah, that's the constant of variation. I can't think of something where that would not be true. Uh, so that would work. Sometimes Q varies directly with P. Does this imply P varies directly with Q? Yes. So if you have if you have a direct variation equation where you have Q is equal to some constant times P, that means as Q goes up, P goes up, and the constant of variation is K. Also, if we want to move this to the other side, we can have 1 over k times q is equal to p. So yes, they are both direct variations of each other with with reciprocal constant of variations. Okay, and that is 5-2 direct variations.